Okay, so sorry for the messiness, but we're going to continue with the daily lessons, page 107. And this is about the second derivative test. So the second derivative test is another way to identify a relative max or minimum without making the chart for the first derivative. So what this is saying is if f prime of c, so some derivative, just the first derivative, is equal to 0. Think about what that is. F prime of c is a horizontal tangent of some sort, possibly a min or a max. So if this is true, and f double prime of that same value of c is less than 0, let's think about what that means. So I've got a possible min or max. Here I've got something that is going to be concave down. So f of x is concave down, and I have a possible min or max. That's exactly what's happening. Then f has a, and I'm going to write this as local maximum because sometimes you'll see relative, sometimes you'll see local, at x equals c. So I can see right here, I've got a function that's concave down. Here's a place where the horizontal tangent exists. So there is your relative max or your local maximum. Likewise, if f prime of c equals 0, and f double prime of c is greater than 0, then f has a local minimum. Be careful, it's easy to say, oh, f prime is greater than 0, positive, maximum. Don't do that. Think about what this means. If f double prime is greater than 0, concave up, f prime of c is equal to 0. This is where the horizontal tangent is happening. You've got a local min. So using what we know here, it says use the second derivative test to find a relative extrema. So in this first one, pretty straightforward. I need to find f prime. So I've got 4x cubed minus 12x squared. The derivative of 2 is just 0. And so what I'm going to do is I was going to find the second derivative, but so I've got 12x squared minus 24x. I need to find the place where the first derivative, so this is 0. So I'm going to set the first derivative equal to 0. I'm going to factor out a 4x squared. And I can see that at x equals 0 and x equals 3, something's happening. It's a possible min or max at both of those locations. If I go into my second derivative, f double prime of 0 would be 12 times 0 minus 24 times 0. I get 0. So nothing is happening there because it's not saying f double prime is greater than 0 or less than 0. It's just something is going on. So, sorry, I was looking on the wrong page for a second. There we go. So here, or nothing is going on because f double prime is 0. So it's not greater than 0, it's not less than 0, it's equal to 0. So that's about all I can go. F double prime of 3, on the other hand, I have 12x squared minus 24x. That's a little bit harder to do, so what I'm going to do is I'm going to say f prime of x down here somewhere, double prime of x. And I'm going to factor out a 12x. And when I do that, what I can see is 3 is a lot easier to enter. 12 times 3 would be 36. 3 minus 1 is 2. 36 times 2. I can see that I am going to have a positive value. Just making sure this is right. Oh, silly me. If I go up here, when I divided out 12x squared divided by 12x, I would be left with x. 24, though, I'm going to be left with 2. Okay, that makes more sense. F double prime of 3, I get 12 times 3 is 36. 3 minus 2 is just 1, so it stays 36. F double prime is positive. F double prime is positive, that means I have a function that's concave up. F prime of 3 is 0. So right here, there is going to be a relative minimum at And then it says find all coordinates. So you have to put your x value, which was going to be 3 in this case, back in here. So if I do so, you can trust me on this, you can go through, and if I substitute 3, then I get a point at 3, negative 25. So I'm going to say there's relative min at f of 3 equals negative 25, or I could say 3, negative 25. And my reasoning as f double prime of 3 is greater than 0, and f prime of 3 is equal to 0. This one is a little bit harder because I've got cosine in here. So what I'm going to do, still the same thing, f prime of theta, and I'm taking the derivative. So the derivative of 2 cosine of theta would be negative 2 sine of theta, and then I've got minus theta, so minus 1. Here I could find the second derivative right away, or I could wait. What I'm going to do, because I know I need to find a place where the second derivative is positive or negative and the first derivative is 0. So I'm going to set this equal to 0. I can add 1 to both sides. Divide both sides by negative 2. Sorry. Oh man. So I need to figure out where is sine of theta equal to negative 1/2. And if you're thinking, well, where's sine of theta equal to positive 1/2? And that happens at pi over 6. And the way that I do this in my head is I think about a triangle. And I've got pi over 6 here. Opposite side is 1. Square root of 3 would be opposite pi over 3. 2. Sine is opposite over hypotenuse, so I would get 1/2. But I need it so that it's negative. Awesome students take calculus. Oh, that was a terrible C. So I need the places where from the interval from 0 to 2 pi, where this is going to be negative. And I can see all is positive, sine is positive, but here. So what's going to happen is theta can be 2 different values. It could be 7 pi over 6, because that would put me in the third quadrant. Or it can be 11 pi over 6. Once you figure out that part, then you can say, okay, well, I'm going to keep going with this. I'm going to take the second derivative. And now we get the derivative of negative 2 sine of theta is negative 2 cosine of theta. And the derivative of negative 1 just goes away because it's 0. So what I want to do now is I want to say 7 pi over 6. And you're going to figure out positive or negative. So I'm putting this into f double prime. F double prime of 11 pi over 6. Again, substituting for f double prime. So take minutes to do this. Make sure that you totally understand how to do this, and you would be able to do this on a test or some other place. Oh, sorry. So f double prime of 7 pi over 6. If I find this, I would get negative 2 cosine 7 pi over 6. And what I figure out, so once you find this value, you should get that this one is going to be positive. I'm kind of skipping ahead because I'm super tired. F double prime of 11 pi over 6. When you find that, you get this as negative. It's a negative square root of 3. Or square root of negative 3. I said that weird. Negative square root of 3. So both these values, I can see here f double prime is 7 pi over 6. As soon as I see greater than 0, I'm thinking concave up. So there's going to be a minimum at 7 pi over 6. Concave down, there's going to be a maximum at 11 pi over 6. So I'm going to say f of x this is minimum. And because this says coordinates, you actually have to find the value, like 7 pi over 6. go up to f of x, put in 7 pi over 6, and I would leave my answer like this. I have an x value and a y value. So a relative min, I'm going to say as f prime 7 pi over 6 equals 0, and f double prime of 7 pi over 6 is greater than 0. I'm running out of room, but it's going to be the same thing for the relative min, except I'm going to say as a relative min, in the place it's going to be 11 pi over 6, and then the y value, you actually get 2 cosine pi over 6 minus, or 11 pi over 6 minus 11 pi over 6. It's funny, this whole thing comes out to negative 11 pi over 6. So in this one, this is where the relative maximum is happening. And the reason is relative max as f prime 11 pi over 6 and f double prime 11 pi over 6 is less than 0. Okay, that's about all I can stay awake for tonight, so I'm going to try this again later, but hope this was helpful. I'm sorry for a little sloppy, and I'm sorry I'm super tired, but I'm sure you guys are too when you work through it, so way to be awesome at life, and thank you for working hard. I really, really appreciate it, and I think good things happen when you work hard for the sake of working hard. So, good job. Keep it up. See you later.